All right, welcome back to Mathville. This is a review of rational expressions that you had both, definitely in Algebra 2, maybe in Algebra 1, but these are things that we need to go over so that we can move forward in trig. So here we go, folks. Starting off, rational expressions, we're going to be doing simplifying, multiplying, dividing, add and subtract like denominators, and add and subtract not like denominators. Should be no surprise there. Okay, a definition. A rational expression is the quotient of two polynomials. Quotient meaning divide, meaning fraction. X minus 4 over 2 is an example. 4 over x minus 2 is an example. X over x squared minus 1 is an example. And x squared plus 1 over x squared plus 2x minus 3 is an example. Anytime that you have two polynomials and you put them one over the other, that is a rational expression. Okay, we have to be careful of the domain because the domain are the values of x, but we have to make sure that the denominator is not equal to 0. So one of the things you have to do before you begin is say, well, is there any value of x that can make the denominator 0? And then you have to restrict that. For instance, what must be excluded here? Or in other words, what can x not be equal to? 4 over x minus 2. Well, if x minus 2 is equal to 0, that means x equals 2. So x cannot equal 2. That would be the restriction or the disinclusion or whatever you want to call it. Or another example, x over x squared minus 1 would factor into x minus 1, x plus 1, so x cannot be x cannot be 1 or minus 1. All right, so go do your first checkpoint and hit the pause button and come back. All right, now we need to simplify rational expressions. The numerator and denominator have no factors in common. This is the first possibility. They have no factors in common. In other words, they're both totally reduced. So if we have x over 2x, well, we can cancel out the x's, and that would simplify it. So this would be 1/2. If you simplify a rational expression, you need to completely factor the numerator and the denominator, and then divide both by the common factor. What I didn't say here, and what I probably should have said here, is, in this case, x cannot be equal to 0, because that would make this undefined. Okay, so sample 2. Let's simplify this. X cubed plus x squared over x plus 1. First thing I'm going to do is factor. I'm going to pull out an x squared from the numerator. So I'll have x squared times x plus 1. And in the denominator, I still have my x plus 1. And notice I put parentheses around it. That's just to say that that's just going to be one factor that we're going to deal with. And now I can cancel those two. So my answer is x squared. But also remember that x cannot be equal to -1. So you can have an answer, and you're also going to have a restriction in all your problems. Let's try another one. This will be x squared plus 6x plus 5 over x squared x squared minus 25. And if you remember how to factor a trinomial, you need to find two numbers that multiply together to be the last term and added together the coefficient of the second term. And so that would be 1 and 5. So this is going to be x plus 1 times x plus 5 over, and x squared minus 25 is the difference of squares, so that's x minus 5 times x plus 5. So stop. What do you have to restrict? Well, the restriction is going to be x cannot be 5 or -5. Okay, now we can cancel. So my answer is x plus 1 over x minus 5, or x cannot be 5 or -5. Please notice that had I not done the restrictions before I did the cancellation, I would have missed one of the factors. I would have only thought that x cannot be equal to 5. All right, so go do your second checkpoint. All right, let's multiply rational expressions. First thing we're going to do is factor everything, and then determine the domain restrictions. In other words, what can x not be equal to because it's going to make the denominator 0. And then divide the numerator and denominator by whatever the common factor is, which is the same thing as canceling. And then multiply the remaining factors, numerator and denominator. I will tell you that sometimes you don't have to multiply the denominator. You can leave it in factored form. But this is what you need to remember. Okay. Example. The next example is multiply x minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. So the first thing we're going to do is factor. And we factor, nothing factors in the first elements. And in the second, x squared minus 1 is x plus 1 over x minus 1, and we're going to take a 3 out of the denominator. So we have 3 times x minus 7. Now what will the restrictions be? Well, x cannot be 1, and x cannot be 7. Now we can cancel the x minus 7 and the x minus 7, and an x minus 1 and an x minus 1, so that leaves us with x plus 1 over 3. And once again, notice, if you go ahead and cancel before you set the restrictions, x plus 1 over 3 has no restrictions, so be careful about that. So it's x cannot equal 1 or 7. So go ahead and do your checkpoint number 3. Let's divide rational expressions. Okay, here's example number 4. And before we do example number 4, I want to do a simpler one with just numbers. If I have 1/2 divided by 3/4, remember, this is the same thing as 1/2 divided by 3/4 written with a division sign instead of a fraction bar. And we're going to keep, change, flip. Remember that from middle school. So that'll give us 1/2 times 4 over 3. And then we can cancel the 2 and the 4, which gives us 2/3. So just to remind you of that. Okay, so let's do example 4, which is x squared minus 2x minus 8 over x squared minus 9 divided by x minus 4 divided by x plus 3. Okay, factor the first. Two numbers that multiplied together are -8 and added together are -2. And the bottom is difference of squares divided by x minus 4 over x plus 3. Okay, right now stop. You can't have x cannot be 3 or minus 3. That's our restrictions. Remember that. So we have x minus 4, x plus 2, x plus 3, x minus 3 times x plus 3 over x minus 4. Now we can do our canceling. We have our x minus 4's cancel, our x plus 3's cancel, and our answer is x plus 2 over x minus 3, and x cannot be equal to 3 or minus 3. Okay, go ahead and do checkpoint number 4. So now we're going to add and subtract rational expressions. And this is going to be with the same denominator. This is the easy part. And then we'll do one with different denominators that don't have any like factors. That would be like 1/2 plus 2/5. Okay, so 5x plus 1 over x squared plus 9 minus 4x minus 2 over x squared minus 9. I have the same denominator, so all I have to do is put the numerators together. And notice that I put a parentheses around the 4x minus 2. That's because there is a negative sign right there. Didn't get that right where I needed it to be, but you see that there's a negative sign right there. I'm trying to do that with my finger. Sorry about that. So I can add the 5x minus 4x, which gives me x, and the 1 plus 2, which gives me 3, over x squared minus 9. Now I need to factor the x squared minus 9, which means x cannot be 3 or minus 3. But now I can cancel my x plus 3, so my answer is 1 over x minus 3. How about different denominators with no like factors? Let's do a little practice problem here. 2/3 plus 4/5. 3 and 5 have no common factors. So what I'm going to do is I'm going to multiply 3 times 5 is 15, multiply the denominators, and then 5 times 2 I have to multiply, I have a 3, I need a 5, so 5 times 2 is 10, and 3 times 4 is 12, so this would give me 22 over 15. So doing this problem, x plus 2 over 2x minus 3 minus 4 over x plus 3, my common denominator is going to be 2x minus 3 times x plus 3. There's no common factors there. And I'm going to have to multiply x plus 3 times x minus 2. And I'm going to have to multiply and subtract 4 times 2x minus 3. I'm going to go ahead and just put that over the same denominator to save some space here. So this will be x squared plus 5x plus 6 minus 8x plus 12. Because it's going to be minus 4 times 2x minus 4 times minus 3 is plus 12 over our 2x minus 3, x plus 3. Which gives me x squared minus 3x plus 18 over 2x plus minus 3 times x plus 3. And x cannot be 3/2 or negative 3. Okay, so go ahead and do your checkpoints 5 and 6 for this. Okay, so that's the end of this, and see you in class.